We recently had a video on the topic of inductive reasoning, which was a process of finding a rule or drawing conclusions from a pattern. This video will look at deductive reasoning, which is the process of using logic to draw conclusions from given facts, definitions, and properties. This is the kind of reasoning we'll be using when we get to algebraic proofs and geometric proofs. But let's start with looking at a few laws. In deductive reasoning, there's a law called the law of detachment. If we are given a true conditional statement, if P then Q, and then we are told again that the hypothesis is true, we can conclude that the conclusion is also true. Seems a little bit redundant when we first read about this law. So let's look at an example. So here is our given conditional. If I sell my bike, I'll have $100. What we're implying in this statement is that we're getting the $100 from the sale of the bike. So if we then go to the statement, I sold my bike, similar to saying that the hypothesis is true, right? The hypothesis was if I sell my bike. Our conjecture is then therefore that we would have $100 because we were already told if I sell my bike I will have $100. So this would be a valid conjecture based upon the law of detachment. Now it might start to make more sense, this law, if we looked at another example which ends up being invalid by the law of detachment. So let's look again at the same given conditional. If I sell my bike, I will have $100. Now, if the next statement that we're told is true is that we have $100, we might be tempted to make the conjecture that I've sold my bike. But this would be an invalid conjecture because we could have received the $100 some other way. Okay, the second law we'll look at in this video is called the law of syllogism. And syllogistic logic follows the same pattern as transitive property of equality. So if we're given two true conditionals, if P then Q is true, and if Q then R is true, we can therefore conclude if P then R will also be true. Here's an example. And I do like to use correctly constructed Venn diagrams to make conditional statements, and when we have this law of syllogism applied, I think you'll start to see that when we work from the inside out of a Venn diagram, we'll always get a true conditional statement. So in this category of animals we have vertebrates. A more specific category of vertebrates is mammals, and a specific category of mammals would be dogs. So here's our given. If the animal is a dog, then it is a mammal. I like to draw an arrow from if it's a dog, then it's a mammal. That is true. If the animal is a mammal, then it is a vertebrate. So now if an animal is a mammal, it is a vertebrate. That is also true. Therefore, by the law of syllogism, if the animal is a dog, it is a vertebrate. So this conjecture would be valid by the law of syllogism. Now let's look at an example where we would end up with an invalid conclusion using the law of syllogism. So we have three different statements, P, Q, and R. A number is divisible by 4, a number is divisible by 2, a number is even. Let's look at an invalid use of logic or deductive reasoning. If a number is divisible by 4, then it is by 2. And we're given that that is true. We're also given that if a number is even, then it is divisible by 2. And we could search all day long for counterexamples. We will not find any. These are both true conditional statements. However, this conjecture, if a number is divisible by 4, then it is even, does not follow that transitive property pattern. If P then Q, and if Q then R, then if P then R. This arrangement says if P then Q, and then instead of taking Q and making it our next hypothesis, we introduce a totally brand new hypothesis, which is R, a number is even. So again it goes if P then Q, if R then Q, can we conclude if Q then R? The answer is no, we cannot. Even though this conjecture might be true, the use of the law of syllogism was not used correctly, so the logic used would be invalid. Now before we get to proofs, one of the really kind of fun uses of deductive reasoning is solving a logic puzzle like this. And so we got some given clues up here, and it is assumed that these are all true. And so what we need to do is make connections using either laws, the law of detachment or law of syllogism. Sometimes it's hard to keep track of which one we're using, but let's get started. One of the children wore a t-shirt that was the same color as their favorite animal. Polar bears are white. That's the real only obvious connection I can see. Stephen was not wearing red. Stephen went to the Australian pavilion. Stephen Australian. Australia, there are kangaroos, so Stephen was kangaroo. Now the nature of these puzzles says there's one valid animal and one valid color for each. Ashley did not visit the lions. Ashley wore a yellow shirt. Therefore, lions do not correspond with yellow. While visiting the king of the jungle, Chase saw the girl with the red shirt. Since a girl has a red shirt, we can conclude that a boy is not wearing a red shirt. And since Chase saw the girl with the red shirt, Chase is not the girl with the red shirt. Therefore, Michelle must be wearing the red shirt. Since Chase saw lions and Chase is not wearing red, lions do not correspond with red. The girl with the red was at the monkey exhibit. Monkeys correspond with red. Since Ashley's wearing yellow, she was not the monkeys, so therefore Michelle has to be monkeys. And monkeys correspond with red. Michelle liked monkeys, she was wearing red. Paul, who did not like elephants. Paul therefore must have liked polar bears, which is the same color, white. Polar bears corresponds with white. Heard the boy in the purple t-shirt, so a boy must be wearing purple, which leads us with Stephen as purple. Stephen saw kangaroos, kangaroos corresponds to purple. By process of elimination, Chase had to be wearing black, so lions corresponds with black. Michelle liked the monkeys, so we've eliminated all other possibilities. And now Ashley was wearing yellow and went to see the elephants. Thanks for watching. Keep practicing.